Hi everyone, my name is Thomas Kim. Today is April 17th, 2020. This is my 19th episode about the programming language C++ 20 standard. Also, this is my second episode about C++20 concept tutorial. In this episode, I will also discuss how to use C++ language 100% or over 100%. Most C++ programmers I came across, they could not use over 20 or 30% of C++ language. But if you have some basic fundamentals about C++ language, you can take full advantage of modern C++ language. So understanding the fundamentals is more important than anything else in learning C++ language. As you may know, I created C++ library extensions using C++17 standard. This is the library website. While creating C++ library extension, I used C++17 standard. While creating this library, I cursed a lot about C++17. Why? Why I cursed C++17 so much? Because I knew if I use C++20 standard, I can implement C++ library extension much simpler, much easier. For example, I filmed this video, Concept in C++20 Standard in Action. This video, October 15th, 2018. So it has been almost 1 year and a half since I filmed this video. This is my second episode about C++20 concept tutorial. If I used concept to create C++ library extension, I could implement my library much simpler and much easier. Broadly speaking, C++ language is composed of two parts: standard template library and core language. So STL is standard template library, CL is core language. Core language is also composed of runtime construct and compile time construct. R is runtime construct, C is compile time construct. Runtime construct is composed of single-threaded runtime, multi-threaded runtime. RS is single-threaded runtime code. RM is multi-threaded runtime code. Compile time construct also has compile time construct 1 as in C++98 standard, compile time construct 2 as C++11 standard, compile time construct 3 as in C++14 standard, compile time construct 4 as in C++17 standard. C1 is C++98 compile time construct. C2 C++11, C3 C++14, C4 is C++17 standard compile time construct. In case of standard template library or C++ standard library has S1 C-style library such as strlen or strcpy, etc. C-style library, and S2 C++98 style library, or we can say single-threaded library, S3 parallel algorithms, S4 like container classes as in C++17 standard such as std variant, std any, etc. Here S1 C style library, S2 C++98 style single-threaded library, S3 C++11 style container classes, S4 C++17 style parallel algorithm. I classified these things to help you better understand. This classification does not need to be correct or accurate. My classification is just to help you better understand modern C++ programming. So, we can say C++ language is composed of standard library, then runtime code or runtime construct, and compile time construct, like this. I will copy this part and paste it here. So, common C++ programmers toolset. Please understand that this part is core language. This part is standard library. This part is core language. This part is standard library. Common C++ programmers I came across, they cannot use C++11 compile time construct properly. That means they cannot use C2, let alone C3 or C4, C++14 and C++17 compile time construct. They do not use or they do not understand. So they do not have these parts in their toolset. That means they cannot use parallel algorithm in C++17 standard. That means they cannot use C++11 container classes properly. They use C-style standard library and single-threaded library. That means they cannot create multi-threaded runtime code properly or efficiently. In modern C++, before C++20 standard, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 parts in C++. But most common C++ programmers can use just 1, 2, 3, 4 parts. 4. It means they are using 2 over 5, 40%. Actually, most C++ programmers I came across, they cannot use less than 40%. They use 10 to 20 or maximum 30% of C++ language. In C++98 standard, compile time construct C1 was very small or tiny. But beginning C++11 standard, compile time constructs are steadily growing. For example, these are new keywords in C++20 standard. Concept requires constant init. These are all compile time construct. Co-await, co-return, co-yield. These are for coroutine. This table lists new features in C++20 standard. In case of context pair, now changes to provide more compile time constructs. So, if we do not fully understand compile time constructs in C++ language, we cannot take full advantage of modern C++ language. If you keep watching my videos, I will help you learn modern C++ language, including C++20 standard. While watching this video, please pay special attention to these terms. Type template parameter, non-type template parameter, prototype parameter, type concept. In this episode, we will also use fold expression. For more information about fold expression, please double-click this link. Fold expression was first introduced to C++ 17 standard. In this fold expression, OP is operator. Operator is binary operator. We will use this syntax in this episode. Also, I will introduce concept header file. For more information about concept header file, please refer to this document. We will refer to this document more frequently in future episodes. We will use same as. This concept. Implementation of same as is pretty simple. If you are new audience to this series of videos, the programming language C++ 20 standard, you have to watch the first episode of this series. In the playlist, you have to watch all videos starting with the setup in the title. Setup. Otherwise, you may not be able to follow my current session. In episode 09, Implement C++ Standard Template Library, we implemented std index sequence, make integer sequence, make index sequence 4. Also, in episode 13, we implemented isSameV this type function. I also explained how to implement std remove cv reference t. You will find standard template library isSameV introduced in C++ 17 is very much limited. So, in this episode 13, we implemented isSameV. If you want to know how to implement isSameV, I highly recommend you to watch this video because we will implement this powerful type function in my current episode using C++ 20 standard. Using C++ 20 concept is a blessing for C++ programmers. After 5 minutes coffee break, you will witness how powerful the concepts are in C++ programming. I will see you after 5 minutes coffee break. It's actually smoking break. Now start Visual Studio Code. Open your working folder. Click on empty space. Then click this button. 019. Prototype. Parameter. Hit enter. Click this button. Proto. PARAM. .cpp. Hit enter. Ctrl B. Include. Talkplay fun. Output HPP. Include. Concept. C++ 20 standard. Concept. Header file. Sorry, it should be concepts. Talkplay fun. S stream. Auto endl. Talkplay fun endl. Namespace. Types. Talkplay fun types. Void test concept basic int main. Copy this function name, paste it here. Stream same as int std same as int and there. For more information about same as, please double-click this link, Standard Library Header Concepts. Same as is introduced in C++ 20 standard. The header file is concept. Double-click this link. I will copy this text and paste it here. I will copy the link, paste it here. for your reference. Now start Visual Studio Code. dir cd 019 photo type parameter cl ehsc sdd c++ latest fe m.exe, hit enter. Sorry, it should be lowercase. We have to provide a file name. File name is proto param.cpp. Proto param.cpp, hit enter. Program is built successfully. I will copy this command, copy, and paste it for your reference. M. So int is the same, true. Now start this command prompt for clang compiler dir cd 019 photo type parameter clang sdd c++2a photo type proto param.cpp ltbb, don't forget this switch, o c.exe, hit enter. So it complains C++20 standard concept header file, concept file not found. As of today, 2020, April 17, Clang++ does not implement header file concept. No problem. No problem at all. You are learning C++ by Thomas Kim. You are my audience. My audience is special. If not defined clang major, then we include else and if. So clang compiler defines clang major. So if clang major is not defined, then we include the concept. This is clang compiler. Namespace std. We extend standard library. For your information, please control-click this link. Open it. So same as is defined like this. It use type trace is same v. Please note that t, u, u, t, same handler. So we create namespace detail template type name t, type name s, concept same helper. std is the same b, t, s. We defined a concept. T is type template parameter. T and s are type template parameters. The first type template parameter is t. The first type template parameter is called prototype parameter. So t is the prototype parameter of same helper concept. Now you understand what is prototype parameter. The concept whose first template parameter is type parameter is called type concept. Please remember the word type concept and prototype parameter. Now here template type name t, type name s, concept same as. We call this function ts. This is conjunction st. We have to prepend detail. Prepend detail. Now in the command prompt, with clang compiler, build again. I made a typo. I fixed. We build again. CLS C. Now it works successfully. Up to this point, you just learned when C++ standard template library does not provide the features you want, then you can create them by yourself, as I just demonstrated you. I will copy the command string, copy, then paste it here for your reference. Please understand that std same as can take two template arguments, one argument, two arguments. Concept same as is very limited. We want to further extend this same as concept like this. We create namespace std namespace detail template type name t type name types struct st same. Don't forget semicolon here. Static context pair bool value false. This is primary template. The primary template determines the count of template parameters or arguments. This template can take this one or more template arguments. Now scroll down here, template, type name T. We use this concept same as. We provide T. Now 3 dots, ellipses, types, struct, st, same, T, types. This is specialization because we provided template arguments. These are template arguments. This is specialization. Please understand that same as is defined here or header file concept. It is periodic. Types, periodic, type, concept, same as. I will discuss this part in the current session or in the future session. Now, static, context pair, bool, value, true. If this specialization is to be selected, all type in types spec should be the same. Don't forget semicolon here. Template, type name T, struct, st, same T, static, context pair, bool, value, true. This is specialization because we provided template argument T. Because the primary template determines the count of template parameter, it can take one or more template argument. We can safely provide one argument. Don't forget semicolon here. Now here in this scope, template, type name, T, type name, types, concept, all same as. We call st same. Sorry, it is not concept. Context peer, full, all the same. Sorry, I would just say is same v, is same v, but it can conflict. All same v. I will name like this. T types. It has value. Please note that st same is defined in the namespace details, so we have to copy and prepend here. This is variable template. Now template, type name, types, concept, all same as, all same v, types. Now scroll down, or we can say type name T, like this. Now we can test like this. String, all same as, int, std, all same as, int, and there. I will copy once again, paste, all same as, double. We can pass one argument to, all same as, just one type. Now in the command prompt with the Microsoft compiler, hit enter. 65. I forgot expansion. We build again. CLSM. So when we provide one type argument, true is returned. When int, true. Int, double, false, because double is different type. Now scroll down. Let's learn how to use this all same as concept. Template, type name T, std, all same as. We provide T. This is variadic type concept, variadic or variadic type concept. Types, auto, summation, T, A, types, args. Now return A plus, we need parentheses. This parentheses is special. We provide the first argument A plus operator, then expand operator args. We are using fold expression. This is initial value, operator. These operators are binary operator, and args. Sorry, we don't need this. Now void test all same as, auto s1 summation 1 2 3 4 5 6 7 8 9 10. We are calling this function stream 1 plus 10 equals s1, and there. Now we copy this function, copy, paste it Here, we will disable it. We are using clang compiler. Hit enter. We rebuild using clang compiler. CLS C. The result is correct. Now we are testing with the Microsoft compiler. Works perfectly. Now I will copy, disable, paste. Now I give different type. See, one is different. At this line 97, the error message should be trapped. We build using Microsoft compiler. 97 here, this line. Now using GNU compiler, hit enter. Clang compiler. Also again, line 97, this line. So we extended standard template library. It can take one or more types. For example, we can try. I will copy this part once again. Copy, paste. 2. It can take one type 2. One argument. I will disable this part. Ctrl K, Ctrl C. If we build using clang compiler, it should work. Sorry, it's S2. We build again. CLS C. So this all same as concept can handle one or more types. In case of SDD, same as in C++ standard library, it can handle only 2 types. We greatly extended C++ standard library. Some of you might argue with me. We can use same as in C++ template library. I will enable this part. Ctrl K, Ctrl U. Don't forget, we have to fix like this. Now in the command prompt, we build again. It built successfully and works successfully. But when we define more advanced constraints, we still need all same as. In future episode, I will give you more explanations about these. Since you are my audience will have C5, C++20 compile time constructs in their C++ toolkit, like this, C5. If you are my audience and watch my videos regularly without skipping, you will learn state-of-the-art C++ programming techniques and technology. By the time you watch this video, you can double-click this link and download the complete source code. Please try it on your machine by yourself. Please subscribe to my YouTube channel. Thank you for watching.